I'm Adam. I'm from the GraphQL server team at Facebook, which is a small social media company in the Bay Area. I'm going to be talking about infinite backwards compatibility and other issues that you face when your schema gets really, really big. So for those of you who haven't deleted the app yet, it's powered by somewhere around 30, 40,000 object types with like 200,000 fields. It's a whole lot, so we faced a lot of interesting challenges and sort of learned a lot about how to continue to move forward without terribly, terribly breaking old clients, which is going to be the first part of my talk. Then the second part of my talk is going to be more about schema management as opposed to just backwards compatibility. So backwards compatibility really refers to the notion that you can move forward, that you can continue to develop, that you can do the things that you want to be doing for the future without breaking old clients. So in order to sort of give you an idea of how backwards compatibility can become an issue with a large schema, I'm going to give you a brief tour of Facebook's sort of overall GraphQL ecosystem, right? So at Facebook, we have a server. It's an app server. It is also our web server. That server has a schema, and everything's going well. You know, people write queries, they write features, they execute those queries, and then all of a sudden, an engineer, we'll call him Dan, has an idea. And Dan's idea for this slide is that he wants to add age to the user type, right? So that you can know how old someone is when you look at their Facebook profile. It's very important. The site started out for college students, so it's like you need to know if someone's a senior, about how old they are. Something like that seems like a good idea, so he just goes in and he implements it. He adds a getAge function to the user type and says that that getAge function is also the GraphQL field representing named age, representing an age. That's all well and good. Then we run a build script, which will produce the changes to the STL that we need. That STL up there is, changed automatically via the script, and then we sync the STL to the mobile clients, right? So like iOS and Android clients will get data classes generated for them, so that when people on, when client engineers on iOS or Android write their queries, they get useful data objects back for them. So you can see that age is there. At that point, Dan has the ability to implement a feature. So we wanted to have age up there on the profile. We can now write a query that will put age up onto the profile. Once we've written that query, we persist the query. We persist queries so that we don't have to ship all of the text back and forth to the server. It also allows us to do validation of the query's text to be sure the query is a valid query when we persist it instead of doing it at runtime. So that's a pretty good savings there too. After that, the client is compiled and shipped, right? So it just goes out. You can see age. There it is. It's right there. Things are great until an engineer has another idea. And now that engineer not only wants to show age, but also days until the next birthday, right? Seems like a good feature. We're just going to put that up on the profile too. Sounds good. So on the client, we are able to get the age, but maybe just literally putting Adam Kramer 38 space YEARS space OLD was not the best choice there. In order to do math on that age, in order to get the days until the user's next birthday, we're going to need to, I guess, parse the string, but even that's not good enough because 38 isn't great. Let's just change the schema, right? Let's just go right back in there, and we'll use a nice little date difference object. And brief show of hands, who here is still using their iPhone 3G? No, nobody? Or like, how about someone who's using Facebook 5 for iPhone? Even on a later, nobody? But I tell you, there is somebody. There's more than somebody. There's probably somewhere between like 3,000 and 5,000 such people. And here's the thing, like you can't just force an app update on the entire world, because when you're a company that, you know, is sort of larger in scale, you don't want to basically just, you know, kick out anybody who can't afford a new iPhone. You can't kick out someone who can't afford a new, can't afford to download the app, because the new apps are, I mean, they're kind of big, you know? They're kind of big. So are we gonna, what are we gonna do? How are we going to handle this notion of breaking changes? This would be a change. If we changed it to a date diff, we couldn't go back. Take a look at that query there. It has age as a leaf. We can't change a string into an object. That would absolutely never fly. It'd just end up null. What's that going to do? So I'm going to talk a little bit about the sorts of changes that would be breaking from the perspective of something like a mobile client that somebody is using that's pretty old. If you're in a world where you're really only dealing with JavaScript, for example, so that nobody's going to be running the same client for years and years and years and years, then you may not face all of these changes. But if you start to compile your apps together, and those sort of compiled together apps are designed to be fast, that's why you compiled them, you might start to face some of these challenges as you grow. So a few examples of something that might break a client. First thing, deleting a type. Right? If something's querying for that type, there's nothing there. We don't know what to do. It's very hard for a client to recover from something like that. Even deleting a field on an object or an interface, when you've got those old persisted queries that were once valid and are now no longer valid, we're executing them anyway. So like when we hit that field on that object and the client expects data, what are they going to do with it if they don't find it? How's that going to affect the client? Even changing the nullability of a field type, saying something that's used to be nullable is now no longer nullable, probably safe so long as the server gets it right, but going the other way and starting to return nulls, like you get null pointer exceptions in your client code. It's not a fun time. Unimplementing an interface, you know, if an object no longer implements an interface, a client that expects that object to be returnable, they're spreading on an interface, now they get nothing. Is that going to be great? You get the point here. The goal is for us to be protecting ourselves from our past selves, or in the case of me and my colleague Kuwei, who spoke yesterday, protecting ourselves from Lee and Dan. So the first recommendation I'm going to have is, as the spec says, the server should respond to pretty much anything at all, right? So a terrible query that doesn't work, that doesn't make sense, that's not valid, figure out something. The server might do a good enough job that an ancient client isn't going to actually break, right? So as an example, one thing the server can do is, if there's no field named age, just return null. You know, get null for the age. Maybe the client is able to handle nulls. Perhaps not. If age turned into an object and the client is expecting age to be a leaf or a string or something like that, you can also return null. But I'm actually going to recommend that you go one step further and that you return useful information if it's at all possible, right? You've got an object, and that object doesn't have a field called age anymore. There's no field there. You could return null for age at the query time, but if you can figure out what the age field used to be, for example, or if you're on a concrete type and the interface doesn't have age, you may as well just return age if you've got it, right? So make your server able to do terrible things, and perhaps eventually those people with the working clients will upgrade on their own without having their app be broken. Second thing I'm going to recommend is warnings at pull request time, specifically about the build. So what I'm saying here is, you've got a pull request out there. As soon as that pull request is out there, get a bot, get some automated system to start checking whether or not your clients are actually going to build, right? So I'm talking about the server having a change to the schema on the server. You want to take that new server schema and say, can we even build a client, right? So at this point, you're basically not only testing whether or not the schema makes sense on your server side, but you're testing whether the clients are able to even produce an app in the first place. At that point, just reject the pull request. You can have a robot do that. It seems rude, but people get used to it. especially if you're protecting them from breaking like literally all of the Facebook apps. It turns out that people get really unhappy if you break all of Facebook for the world, speaking from experience. I'd try not to do that much. But beyond just whether or not the clients are going to build, we can look at whether the change to the schema is going to affect or especially negatively affect things that are actually used, right? So everyone has metrics at this point, right? The data science movement happened. It was like 10, 12 years ago. It was really fun. But at this point, like I'm pretty sure every tech company everywhere has some way to track usage. There's data on everything. Add metrics to your field usage. How many times is a field getting resolved on the server? How many times is that field's resolved value getting shipped out to the client? All that information, have your bot put that into your pull request automatically also. So you know if you're changing a type or a field that millions or billions of people are using. If you're making that change, you need to know how it's going to happen downstream. Ideally, you'd be able to like build a client or build an old client on an old device, but like eventually that becomes unwieldy too because you have too many hundreds of different versions of this or that or the other thing. But perhaps it makes sense. Maybe you're deleting a field that doesn't appear to have any usage or much usage, or you're deleting a field where there's lots of usage, but you're really sure that the client knows how to handle nulls. Everything seems good. Cool. All right. Next step then is to actually use the clients, right? So at Facebook, we have this aggressive dogfooding process via which if you're an employee, you have no choice whether or not you're using your personal phone or not. The Facebook you're using is the Facebook that we're going to ship soon. So we're compiling those clients. We're compiling the new clients. Anyone with the old clients are using the beta versions of those beta clients. So if anything goes wrong, let me tell you, one motivation to fix something you've broken is to have your actual coworkers start messaging you. That's motivation right there. It's motivation to fix it. Fear of that is also motivation to avoid it. For those of you who get too many messages every day, I'm sure that this really, really resonates. But Facebook actually went one step further, and we invented an entire product called Workplace, which is like Facebook, but only for a job, just so that everybody at Facebook would be using Facebook for the job, for a job. I mean, that's not why we invented Workplace, but anything that's changing Facebook, the app, is also going to be changing Workplace, the app. So it's like highly tied to our ability to deliver value on a day-to-day basis. So if you can convince your employees to need your app, chances are you're going to be in a really good situation and you're not going to ship something that's fundamentally broken. But if you do, if you're going to ship something, your employees haven't complained or they haven't complained enough, ship it slowly. So at Facebook, we have what we call a continuous push process, which means that several times a day, every couple of hours, trunk, like all of the code we've committed in the last couple of hours, ends up rolled out all the way to the planet of Earth. I was going to say the universe, but I'm only sure about Earth. We roll it out very slowly. So it's like push phase 1 goes out to very few people. And if something goes wrong there, we're going to notice. And at that point, we can say like, OK, hang on, we've actually broken GraphQL. But finally, if we roll it out to the whole world, and that's when we're able to figure out that something's gone wrong, because it's a really old client or it's a really rarely used feature, but the way that it's broken breaks everything for someone, that's when you kind of start to get creative, right? So getting creative can mean a whole lot of different things. It can mean that you revert what you just did, and then the server works again. Creative solution of just saying, my bad. You can do that. You can iterate. You can say, we need to re-implement this. Or in our case, one useful solution that we found was to just write objects that just do nothing at all so that the object is still there. It's returning null. It doesn't produce an error. It doesn't even produce a warning. Gift. We had this great idea, maybe it was like 10 years ago. It's that you could pay $1 and then an icon of your choice would appear on your friend's profile, and we called that a gift, and it was going to be great. Like everyone could show that they appreciate each other, just pay $1, put a gift on somebody's page. They weren't gifts, they were gifts. That was part of the problem. There were also a lot of other problems, like nobody wanted to do it, but we deprecated we deprecated the product, like gift is no longer even a thing. So it's like if you're loading a profile that has a gift on it, like there's no gift there to show. So in that case, like getting the name of the gift that isn't even there, that it's like it's not even there to show, like you may as well return null. And this sort of solution allows us to keep a schema that's basically the same to not break the client, but instead we're just giving the client literally nothing when they ask for something. It also helps if you've got like a massive, massive client code base and you're like, well, the client code base won't build and we don't want to spend hours and hours figuring out everywhere that the gift product was tied into this or that or the other thing. You can just sort of throw up some sort of vestigial shell like this for a while. So hopefully together this will allow you to have some modicum of pride in your schema. We're missing pride in San Francisco to be here, so enjoy whatever lifestyle you choose to live. That's backwards compatibility. But what about forwards compatibility with a schema? And now we get into the slides that I had to completely rewrite during the last talk because of the last talk. We can talk about STL first approaches, and we can talk about code first approaches. But when are eventually you going to be thinking about the schema when you're developing a product? Right? Like when's a product engineer ideally going to need to be thinking, what am I doing to the GraphQL schema? I would suggest perhaps never. Perhaps they should not think about it at all or only just barely consider whether or not this has anything to do with this thing called GraphQL. I'm going to go back to Dan here and his addition of age to the schema. Kuwei talked about this in her talk yesterday just a little bit. I'm going to expand on it and show you a lot of code written in the hack programming language, which is PHP with type safety, except it's not PHP anymore. That changed in December. But it's really good. It looks like this, pretty much easy to read. You can call it some other form of Java too if you like to. But what we've got here is an interface. The interface is called user. I would like you to pretend, or at least believe me when I say, that this interface is the literal in-code representation of a user of Facebook in the Facebook website. Right? This interface is everything. It powers everything. And right up at the top of it, we've said that it is also the user object for GraphQL. We just put that annotation on there. We also put an annotation, GraphQL field of age, right on the getAge method. What we're doing here is we're saying not that there is a resolver for the age field, but we're saying that the age field is literally just this method on this interface. Okay, so we're going to go over here and see the interface. It's not a good idea to show just screens and screens full of code, but I'm doing that anyway. Please bear with me. So here's the function get time since birthday, which is a date diff. We've successfully mutated the schema, by the way. It's no longer just a string representing the age. This is what it looks like from an engineer's perspective, what they're writing in order to say, I want this method exposed to GraphQL as the age field. What we're doing then, I told you we had a build script before we sync it to the clients. The build script is generating artifacts like this one. So the class below is just a completely independent class that's programmatically generated from the annotations on top of live code. So what we're saying here is that we see the iFacebook user interface turning into the GQLG iFacebook user type class. Now there are a few key components here that are extremely useful, helpful for a build system in order to achieve what I'm now calling an STL Never Approach, which is, first of all, we're taking the annotation that it's a GraphQL field, and we're putting that directly into the code in the generated artifact, so we have static access to it at any time. Second thing we're doing is we're looking at the type signatures in hack. So hack is a strongly typed language. We say that this is a date diff, and that date diff type in hack is exposed to GraphQL via the same method. So up at the top of it, it's got a GraphQL object whereby it's called date diff, and then we can use that annotation in the build script to know that there is a generated runtime artifact for the date diff type in hack corresponding to the GraphQL type. So we're mapping back and forth between the GraphQL type system and the hack type system that we've generated over many, many years. And by mapping back and forth like that, we end up with all of these generated artifacts such that we've got a method named age. It's named exactly after the GraphQL field with a correct type signature, so we get static type checking of all of our GraphQL relationships among fields and edges in our actual code base so that we can't commit something on accident that would produce a type incompatible result. We also see that the programmatically generated class has a programmatically generated name so that the class is tied directly to the hack interface that it comes from. Okay, so that's a lot of stuff. Seems pretty cool. What does it get us? Here's what it gets us. It gets us an executor that's only 6 lines long. Obviously, this is a lie. It's much, much longer than this. But this is really all we actually need. Everything else is, solving the red rainbow problem of being sure that we produce the most useful response that we can. But at its core, when we get a random object in our executor, we can generate its value just by looking at the class of the object, because that tells us unambiguously what the runtime artifact should be named. Then, thanks to the fact that you can use a class name to generate an instance of it or to call static methods on it in the hack programming language, we can just get an instance of the runtime artifact. We take the runtime artifact and we can get an instance of whatever artifact for the type of a field that we're loading, and then we can use that to actually call the method straight up on the runtime artifact to get the age out of it. I also have different colors that I have not once yet in my practice talks remembered to use during this part of the presentation. Awesome. And if you want to do something that's a little more in line with a process where your engineers are actively thinking about the GraphQL schema, if somebody just wants to have a GraphQL specific implementation of a specific method, they can just write a method in the hack code base, and that method can be just the generate age for GraphQL. But here's the thing. You might not need that. You might have it. You might want it. There are good reasons to do something different for GraphQL than you do for the rest of your entire code base. But at the core, the purpose of GraphQL is to build a bridge between server functionality, where you've got people writing in hack and people who love writing SQL joins. There are such people. And you've got this bridge, which is GraphQL, between the server and the client engineers. Right? We're thinking like 2012 is when we started developing GraphQL. The purpose of doing that is to let client engineers think about Facebook social graph as a graph, right? Mind-blowing, right? Not today, but then it was. Which is to say, the whole goal of the system is really to not have the server engineers have to think about what the client engineers need. They're developing their own server-side APIs, which are doing things like getting an age out of an object. And chances are they did a good job. Not every company starts with a website and then realizes that they need to have mobile apps. Certainly not any company for the last 5 years. But that's where we came from. And if you have a website that you would like to make into a mobile app, trust that the server folks are actively developing useful APIs for themselves. And then you can have GraphQL really just be a bridge between the server and the client. I'd make another point, which is that if you're a client engineer and you don't know hack, you don't know how the programming language works, you can go in there and see these little angle brackets, and you know what GraphQL is, and then you see that there are GraphQL objects and fields, and you know what GraphQL is. You can probably just put one on there and ask a server-side teammate of yours, someone who works on the server side of your product, if it's actually okay to do that. Chances are it's going to be yes. So the thinner you make the bridge between your server and your client, the more likely it is that your server and client engineers can do what they're best at, instead of having to have people in the middle who are sort of understanding server needs, client needs, etc., and actually thinking about all that sort of stuff. I mean, if you think about it, the way most bridges are constructed are such that there are 2 lanes that look like highway lanes, and the cars that drive down one side of the bridge or the other are really just treating it like a road. It happens to be a bridge, but you don't need to know much about triangles. Anyway, the long story short here is that as you continue to write your GraphQL schema, as it gets bigger, as you cross the 1,000 types mark, as you cross the 10,000 types mark, we're getting close to the 100,000 types mark when we think about all the different schemas that we have which power things more than just the blue Facebook app. But as you're sort of progressing through all of this process, you basically end up in a situation where your schema design must become an afterthought. Right? This is actually the slide I wrote. One of the downsides, it's like if you do STL first, you're definitely not having schema design be an afterthought. But if you do code first, then maybe it's a risk that your schema design is going to become an afterthought. But how many years did you and Nick review every new GraphQL definition? 2 years. 2 years of looking at literally every resolver on literally every object. It does not scale. It does not scale. So eventually, your GraphQL schema design must become an afterthought. And by working with a very thin layer like this, where you're very tightly coupling your schema definition to the actual code that you're writing, is one way to effectively achieve what I would call perfect federation, where once there's nothing more than just an annotation, you can actually say, okay, you're the team that owns this object. You're the team that owns this method. It's literally your code that you're writing on the server, and no one needs to know what's between it. So I'm just about out of time. I had notes, but they don't show up on the screen. So in sum, do your best job to not break old clients while you try to move forward. Use every tool that you possibly can to be sure that people are not, or to be sure that your engineers aren't breaking anything on accident. And as you grow, as your schema gets bigger and bigger and bigger, do a better and better job of making the bridge itself be the fantastic thing about GraphQL, such that nobody really needs to know or think about it. And if you have any questions, these are the names of the people, but really any questions, you can just ask anybody else who's wearing a shirt like this one. We're all here, we can all answer them.